Ladies and gentlemen, welcome in the second episode of the actor model series in Golang, where I'm gonna teach you everything about actors, the actor model, the mental model of actors, and how we're gonna build these things with the Hollywood framework, right? Which is an amazing framework to write actors in. Right, so basically in the previous episode we discussed what an actor is, how we can create one, and how we can send messages. But now we are going to cover how we can spawn children, what is poisoning, right? Stopping actors, how does it work internally, and because the semantics are a little bit interesting. And then we are going to cover the event stream, right? Because these things are very important. Later on, we're going to cover remote actors. It's probably going to be something for the next episode where we're going to send and discover actors over the network. Yes, right. But before we continue, you know the drill. If you are not yet subscribed to my channel, consider subscribing, give me a thumbs up, leave some questions in the comments, and join the Discord community, links down below. And some amazing news is that I have the full-time GoDev course, which I'm going to launch with a 30% off, because what I'm gonna add to this is that because we're covering actors right now, but what would be nice if we built a complete game engine with a simple game that's connecting to a game engine, so we have a multiplayer environment all built with actors. That's what I'm gonna add to the full-time GoDev very soon. So hey, if that's something for you, check the link down in the description. Let's start. So spawning children. So basically in our previous, I'm gonna put this code online as well, link will be in the description as well. Right, so what did we do in the previous episode? We are going to take damage here and we send in this loop. We're not gonna do this anymore. This is the pit, that's fine. We're gonna actually satisfy the compiler just like we satisfy our wives or girlfriends each day, you know what I mean? So the thing is that, what is spawning at children? Let me actually, do I have a Brave browser open here? Let me do this real quick. I am not prepared, but that's nothing new. Let me close this from the stream last night. Excalibur here, boom. Right, so in an actor, if we spawn an actor, for example, this is going to be an actor, right, act. And if we spawn a child, this basically means that this actor spawns a child, which is going to be another actor. There's no difference in between. The only thing that is different is that the lifetime of this child is going to be determined by its parent. So what does that mean? So for example, if I start this actor, right, and this actor spawn this child, what's going to happen is that if I stop this actor, what basically means that the actor, the parent will first stop all the children in its tree, and then it will stop itself, right? So if you spawn a child and this child spawns a child, we need to do some bird control here, isn't it? Like this. So what's going to happen is that I spawn this actor spawns a child, this child spawns this child. If I stop this actor, what's going to happen is that poison pill here, poison pill here, poison pill here, this will be stopped. Let me take another color here. It's very important to understand. This will be stopped, and then this will be stopped. So you do not need to control all your actors in the hierarchy. You just need to control the parent, right? Normally in a traditional actor model, so as we see in other frameworks or Erlang, which is basically the grandfather of all these things, is that each child will have a supervisor, right? In Hollywood, it works a little bit different. In Hollywood, we do not really have the concept of a supervisor, because basically how it's programmed is that each child will have some kind of a supervisor you do not really control that will make sure we can restart these actors when they crash, right? But you need to see as the parent of an actor as its kind of manager, as its supervisor. It's not really technical actor stuff, but it works well in this concept, right? So just to take a little bit in mind here. All right. So for example, when do we want to have a child, right? Why do we want to spawn a child, right? It's very simple. Let's say we build in a game server and we have this player. What will a player always have most of the time? An inventory, right? So let's create that. We're going to say, to be honest, let me do it in here. We're going to say type inventory, which is going to be a structure, right? And I don't know, let's do something like, what does an inventory have? Bottles. We're going to have some bottles, and it's going to be an integer, right? So each time we start a player, we also need to have an inventory, right? So what we need to do is we need to actually, first of all, make this inventory an actor, right? And the only thing we need to do is implement this receive function. So we're going to copy this receive function here. And we are going to paste that in here. We're going to say I for inventory. We do receive here. We're going to say that the inventory actor is started. The inventory actor is stopped. Take damage, we don't need this. We also need to make sure that we do something like this for the compiler again. So now this inventory is technically an actor because it's implementing the receive method. The only thing we need to do is, you know what I mean, make things easy. Copy this, paste that in. New inventory. Actor producer, we are going to return an inventory. Do we want bottles? Initial bottles, going to be an int. I'm going to say here, bottles. I don't know, let's give him one bottle. One bottle of wine. Or whiskey. So this is good. So basically now we are ready. So what we're going to do is, each time we start a new player here, very important is, very tempting is, to start this inventory actor in this new player constructor. But that's not what we want to do in the actor paradigm. In the actor mental model is that we have this started message. Remember, that's the message that Hollywood is going to send to your actor each time it's started. Inbox is ready. This player is ready to receive messages and act upon it. So what we're going to do is we are going to start the inventory in the actor when the actor receives the started message, if that makes sense. So we're going to actually say, very important, this context here is exactly what we need, right? There is no need to pass engine stuff or other variables into your actors because the context will have everything you need. So we are going to say C spawn child, right? And spawn child takes in an actor producer, actually the exact same parameters we have spawning normal actors. So we're going to actually say we want to spawn a new inventory with... To be honest, what did we do here? Bottles is 1. Actually, this needs to be bottles, right? I was just confused here, no problem. So we're going to actually spawn this with 1 bottle. We're going to give it a name, a kind. Remember, the type. What kind of an actor is this? It's the inventory actor. Inventory, and then we can give it some options, which we don't care about, right? This spawn child will give us a pit, right? A pit. And the good common practice is to store in your player here, for example, the inventory process ID is going to be a pointer to an actor pit. Why is it a pointer? Because that's what protobuffer is giving us, right? So protobuffer is always pointers. It's annoying, but it is what it is, right? So we could say something like this: p.inventory pit is going to be directly this newly spawned inventory, right? So before we do, let's actually spawn this thing, wait 2 seconds and see what's going on, right? So let me clear the screen here, go run, main.go, right? So now we see that we have a player actor is started and the inventory actor is started, right? So that's exactly what it is. For example, let's say we're gonna have a player as the main actor, the parent, then we're gonna have an inventory. You could have something else like I have no clue, some other actor, right? This is exactly how you're going to do it. Each time the player starts, where are we? Here. Yes. We are going to spawn all the children. And we are going to store them as process IDs inside of the player's state. Later on, if we use cluster, we are not going to do this like this. Because why? Because in a cluster environment, your server can come up, can come down, actors can be respawned on a different type of IP address, and the process ID will be basically out of sync. But that's for later on. Let's keep it simple. All right? That's that. This is how you spawn children. So how do you send messages to this thing? Well, it's actually very simple. Let me do, if we take damage here, actually, let's do it a little bit different. Let's turn this into drink amount, I don't know. That's fine. Drink bottle. Let's drink bottle here, just like that. And we're going to say, if we have a drink bottle, what we're going to do, we are going to send or forward this message to our player, to our inventory. How can we do that? Well, we can just do like a C send, right? Which is the context will send this message. You can also do this, c.engine.send, right? The only difference is that if you do it with the engine, the receiving actor does not know who is sending this message. If you use the context, right? If you use the context, the receiving actor will exactly know who is sending this message. It's coming from the context, if that makes sense, right? So we're gonna actually, we can do this. We're gonna see send and forward the message to the player dot inventory pit, right? Just like that. It's gonna work perfectly fine. But we also have a shortcut for this because the only thing we do is forwarding this message, right? So what we could do is just do C forward, right? And then just give the p.inventory pit. When do we use forward? When do we not use forward? Well, if your player, let's say you're gonna receive this message, drink bottle, maybe you wanna adjust the state of the player, right? Maybe you wanna have a counter or something else you wanna increment, or I have no clue what you wanna do. And then you send a message to the inventory because the inventory also needs to do something like subtracting the bottles or something, right? Depends, right? In our case, we are not going to do something in the player state, so we can actually just forward this message to the inventory process, right? Just like that. Actually, to be honest, I'm going to comment out this message because we don't use it. So we're going to forward the drink bottle to the inventory actor. So we're going to say case drink bottle. We're going to say mnt println inventory received drink bottle message, right? And of course you would do something like e.bottles minus is msg.amount, something like that. Adjust the state, right? Okay, drink bottle, that's fine. Now the only thing we need to do is say engine.send a message to the player pit, and we're going to make a drink bottle message, and we're going to say that the amount is going to be 1 or something like that, right? Let me see if that's going to work. Go run main.go. Right, perfectly fine. The player actor started, the inventory actor started, and then we received a drink bottle message from the inventory actor. Pretty straightforward, right? So that's that, right? Cool. Next thing, children. The next thing we need to cover is poisoning actors, right? So what is poisoning actors? Why is it called poison and why is it not called stopping, right? Well, let me explain this to you. It's very important, right? Because if you're going to work for companies that uses actors, you really need to understand that, right? So we know in the actor model is that we're going to have an inbox, right? An inbox. I really need to do something about my writing. An inbox. And each time we're going to send a message to an actor, all right? It will be in the inbox, right? Message, right? So the thing is that if I want to stop an actor, and I want to stop it gracefully, because each time the actor will basically read from the inbox and it will process this, right? It will process this. Okay. But what if we have like 4 messages in our inbox and we stop the actor abrupt? What's going to happen is that if I stop it, I will never process these messages. So 4 messages will be lost. Right? Let's say I have a cryptocurrency exchange or a stock exchange or something, and I have 4 orders sitting ready to be processed, and I stop my trade actor or something. These 4 orders will be in the trash can. They will never be processed, and somebody will be lucky or unlucky. You know what I mean? If they made a wrong trade, they're going to be lucky, but if they made the correct one, then it will never be processed, so they will never have this thing active, okay? So that's why in an actor, because the actor model is all about fault tolerance, high availability, low latency, so what we're going to do is we're going to send it a poison pill. If I call poison, it will send a special pill here. I'm going to, a blue, a poison pill. Poison pill. That's exactly how it calls. Poison pill. And I'm going to basically send the pill. It's just a message a special message, a poison pill message, and the pill will be here. So what's going to happen is that even if we want to stop this actor, we send it the poison pill, but the poison pill will be in the queue. So it's going to process this order, right? Then it's going to process this order. It's going to process this order, this message, and then it finally sees this poison pill, and then it knows, okay, I need to stop. So a poison pill will be sent, and it will basically poison. That's why it's called poisoning. It's poisoning the actor. It's poisoned, but it will only be dead when it receives this pill, processing every message in its inbox first. And that's amazing. That's basically, you can see it as a graceful shutdown, right? That's a poison pill. How do we do this? Very simple, right? So we're going to actually send this thing first. Then we're going to sleep for 2 seconds. And then we're going to poison actually. Poison. And we're going to poison a pit. It's just the same thing. It's all the same content. Very simple. It's all about the process ID. We're going to poison this, right? Pit. Okay? That's what we're going to do. Poison is a non-blocking. Poison is a non-blocking operation. Everything in the actor model is non-blocking. But we can block. How can we block? If we check what poison does, it will return a context.context, right? And what does a context have? A context have a DOM, right? And we can actually wait until this actor is poisoned. Normally, you would just poison, fire, and forget. But in this case, we're going to wait, right? And what's going to happen is that, okay, we have stopped here, and then we have a stop message here. So let's me try this. Go run main.go. Okay, so you can see what's happening, right? So we start the player actor. Then the inventory actor is started. Then we receive the drink bottle message. Then the inventory actor is stopped. And then the player actor is stopped. You see how simple semantics with the Hollywood framework causes your system to be very, very resilient, very predictable, right? Everything just organically works, if you know what I mean, right? So your system can basically, each time it's stopped, you can save a state, you can make it robust, you know what I mean? That's what it is. That's poisoning. Something you need to know is that, for example, let's say, what's the problem here? What could be a problem? This is not very deterministic, right? Why is it not deterministic? Because we can send a poison pill, but this can have like 1 million messages in his inbox, for example. So we want to poison this actor, but he's still busy 1 hour processing all these messages. So the actor will not stop, right? It will stop, but after an hour, for example, right? So what we could do is, because the creator of this framework was pretty nifty about it, and he basically implemented a poison CTX. And what's a poison CTX is basically you can give it a context yourself, very idiomatic Go. So if you see this, right, boom, it takes in a poison, it takes in a context and then a pit. So why? Because we could do something like this. The context underscore, we're going to ignore the cancel, is going to be context dot with timeout, right? We're going to give it a context background here, and then we're going to say time dot, I don't know, second times 5 or something. 1 second here. Why does it not work? Because we are an idiot. Yes. Right, and then we can actually say, okay, I'm going to give in this context. So what will this do? This will basically say, okay, listen, I am going to poison you. But if you do not stop after 1 second, you will be stopped, right? Is this ideal? Most of the time not, but sometimes you want that, right? So in some use cases are, okay, listen, I want you to stop, you're poisoned, but please do not take longer than whatever timeout I give you, right? This is basically the poison context, okay? That's that. Nice. Okay, step by step. The last thing we're going to discover in this video is something very cool, which is called the event stream. What is an event stream? An event stream is basically an event stream. Everybody can send events to the event stream, and everybody that's subscribed to the event stream will receive that event, right? Why is it interesting? Well, let's say we have 20 actors, right? And we want to basically broadcast a specific message to these actors, to everybody we have, to every actor. Do we really want to basically here, for example, loop or find all the actors and loop over them and send a message? No, we don't want to do that. We basically want to have some very simple mechanic, which is just an event stream like, hey, something happened here in my system. This is what happened. Everybody do whatever you want, right? How can we do that? Very simple. For example, again, the event stream. Most of the time, if you want to subscribe to an event stream, we're not going to do that in the constructors here, but we're always going to do that in the started method, in the started message that Hollywood sends. So how does it work? Well, we can do something like this. C, context, we're going to find the engine, which is the global engine of the actor framework, and then we're going to say subscribe, right? And this is a cool mechanic here, because subscribe takes in a pit, right? Everything is evolved around pits. So what does it mean? It's like, hey, engine, this process ID, I want you to basically send all events on the event stream to this process ID. This pit is now subscribed to the event stream. That's basically what it's doing. What kind of a pit will be subscribed? The player's pit, correctly. I knew you knew. So it's going to be the C pit, right? So we're going to get the pit from the context, C pit. Pit returns the pit of the process that belongs to the context. Very simple, right? So we're going to subscribe this player actor to the event stream, okay? So let's say the event stream, you can send whenever you want. For example, I'm going to make type a foo, which is going to be, actually, to be honest, I'm going to do it very simple. We are going to say here, I think it's broadcast event, and it can be any message, right? It could be a structure, it could be whatever you want. In this case, we're going to send it a string event to everybody. Boom. Let's sleep again, because everything is like non-blocking, so we need to make sure we sleep, so otherwise we don't see anything. The program will just exit, and that's not the thing. So we're going to broadcast an event. So basically, this is just a string, right? So if you want to catch the message, we're going to say case string here, right? fmt println just got a string from the event stream, right? And normally that should actually work. Not. Yes, it is. I'm sorry, because we're sleeping here, right? So now we got a string from the event stream. Very simple. So instead of a string, we could do something like this. Type my event struct foo string, right? We could actually send my event here. Foo is going to be, yeah, buddy, lightweight. Something like this. Of course, now this is not going to work. Now we need to basically say it's going to be a my event. And then we're going to say here, it's going to be msg dot. We don't have msg. We need to do it here. msg, boom. Switch on the type. msg foo, right? Let's do it again. So we're waiting here because, boom, just got a string from the event stream. Yeah, buddy. You see? That's the thing. And everybody can subscribe to the stream, right? So let's do engine subscribe. Let's subscribe the child here, right? We could do this. Boom. We're going to subscribe to the event stream. We're going to do the same thing. Case my event. Let me copy some stuff. I'm a little bit fast here because I want to make sure this video don't take forever. You know what I mean? It just got an event for an event stream. I'm the inventory, by the way. Inventory, by the way. Just like that. And that should basically just work. Boom. You see what's happening? Just got a string from the event stream. I'm the inventory, by the way. Just like that. Of course, can you be 100% sure that who is going to receive the event first? That's something you never can predict. It's all asynchronous, right? So that's it, guys. This is basically what I want to show you today is spawning children. Why? Poisoning actors. How does it work? The poison pill. And how can we use the event stream, right? Very important basics, because we're going to build upon these fundamentals later on. So I hope this video was interesting for you. I really let me know in the comments what you guys are building with Hollywood, with the actor model, because I see in my Discord a lot of people are building amazing stuff, and I want to know what you want to build with this, what could be a good use case in your fantasy. And don't forget to like and subscribe the channel if you love these videos, and if you don't love them, you don't need to. Okay guys, thank you so much for this video, and I'm looking forward to see you in the next one. Peace out.